Welcome to Statics Lectures by Civil Thinking, and today we are going to see another concept in truss analysis. Now we have already made a video lecture on truss analysis using method of joints. Now in this class we will see another method. The second method is method of sections. Okay. Now in the method of sections, what we do, we use this to find the axial force in truss members. Okay, let us say this is a truss. Okay, these are the members, all these lines are the members of this truss, and when we have to find the force, these members have axial forces, only axial forces in them. So we have to find these axial forces when the truss is subjected to an external loading at the joints. Okay, now these forces, because they are in these members, they are called as member forces. Okay, they are called as member forces, and with the help of method of sections we can find these member forces. Okay, now this method is helpful when you have to find force in a particular member or only a few members of a truss. Now previously, in the previous class, in the method of joints, okay, in the method of joints, what we did, this method is useful when we have to find the member force in all members, right? All members. Okay, now when we have to find the member force in a particular member or only a few members, we use method of joints. Okay, now method of sections have some steps. Okay, so let us see them. Let us talk about steps in method of section. Okay, now the step number one is we have to draw the free body diagram and find the support reactions. As you can see, this is a truss and they are the supports. This is a hinge support or a pin support, and this is a roller support. Okay, now we have to draw the free body diagram of the whole truss. Okay, first of all, in the first step we draw the free body diagram of the whole truss. Now for example, this is the truss and we have to draw the free body diagram. What we do, we convert these supports into support reactions. Okay, now let me erase this. So this was a hinge truss and we know there are two reactions, right? In a hinge and in a roller, how many reactions we have? We have only one reaction. Okay, so this becomes what? This becomes the free body diagram of the whole truss. Okay, then what we do, we apply these equations. Summation of forces about the x-axis is 0. I'm assuming horizontal axis, this is the x-axis, and the vertical axis, this is the y-axis. Okay, we will sum up all the forces in the horizontal direction, that's x direction, and equate it to 0 because these are the equations of equilibrium. Okay, now I have already made a video lecture on equations of equilibrium. If you don't know much about equations of equilibrium, these three are the equations of equilibrium. Okay, if you want to know more details, you can watch my video lecture on equations of equilibrium. Okay, now the equations of equilibrium are these: summation of forces in the horizontal direction or x direction, we have to equate it to 0. Then summation of all the forces in the y direction or vertical direction is 0, and summation of moment about any point, about any joint of this truss is 0. Okay, we draw the free body diagram. Okay, then we apply these equations one by one so that we found these reactions, right? Let us say this is r1, r2, this is r3. We will find these r1, r2 and r3 with the help of these equations of equilibrium. Okay, don't worry, when we take example we will actually apply these equations of equilibrium. Okay, and we will see how we will find these reactions. Okay, right now I am just introducing you to the basic steps in the method of sections. Okay, now let's move on to step 2. After you find these reactions, we have step 2. Okay, now step 2 is, now these reactions are known, right? What is the step 2? Let us say this is, for example, this is a joint A and this is joint B. Okay, now step 2 is cut the truss at member where force is needed to be determined. Okay, now in the problem, for example, we have to find the force in AB. We have to find this. Okay, force in AB member. This is the member and we have to find the force in only this member, because we are asked to find the force in only this member. So it should strike our mind that we need to apply method of sections and not the method of joints, because in the method of joints you have to proceed, at every joint. Okay, but method of sections, it is very easy and it saves our lot of time, because we apply method of sections directly at the section where it is needed. Okay, where the force is needed to be found. Okay, now what it says, all of this is written. It says we have to cut this section, okay, into two parts. We have to cut this truss into two parts. Okay, because we have to find the force in AB, so we will cut at AB. Okay, if it was, for example, this is C, if it was for S could find the force in AC member, then we would cut here. Okay, cut the member where it is needed to find. Okay, so we will cut it like this. Okay, we will not only cut one member, we will cut all the members near AB. Okay, so that the whole truss is divided into two parts. Okay, we have to cut the whole truss at this AB. Okay, then we will be left with left side and the right side. Okay, so now there is a rule: the section line should not cut more than three members. Okay, now if I draw a section here, for example, now how many members is it cutting? Now this is one member, two member, and this is three member, right? So this is okay. The section line should not cut more than three members. Okay, so let us do this. Okay, we will cut it. Now we can cut this like this. Okay, or we can also cut it like this. It is our choice. Okay, now let me choose. I will cut it like this. Let me get the eraser. Let us say I cut it like this. Okay, now what we have, we have two parts of this truss, right? Like this and this, right? Now this is the left part and this is the right part. Okay, now this is step 2. We have to cut it into two parts. Okay, now we are left with these, okay, cutted members. We will assume the forces in them are tensile. Okay, like this, only the cut, because this is a cut member, right? They are tensile. Okay, now what member was this? If you remember, it was what? AB member, right? This was AB member, so this is force in AB. Similarly, this will be a force in, suppose here was some D, okay, and here it was E, so this will be another force and this will be another force. Okay, in the subscript we write what? The name of the member. Okay, now this was AB member, so we write force in AB. Okay, so I am assuming all the forces to be tensile. Okay, because this is away from joint. You see this arrow, this is away from joint. When the arrow is away from joint, it means tensile force. Okay, we assume, I am assuming, I assume the forces to be tensile member force. Okay, this FAB is the force in AB member and it is a tensile force. Now what happens when we finally solve everything and we get a numerical value? For example, AB is plus 3, okay, 3 kilonewton. If we get the positive value, it means the force was tensile. Okay, now if we get negative value, for example something minus 3 kilonewton, it means our assumption was wrong and the force is actually compressive force. Okay, compressive force. Okay, now step 2 was basically what? We cut the truss. Okay, we cut this truss into two sections. Okay, then for example we needed to find force in AB. Okay, so this was force in AB. Okay, For example, this is AC. Now this is force in AC, right? Let us say this is D. So this becomes force in CD. Okay. Then we only consider one part. We analyze only left part or the right part. Okay. Now, for example, here if we want to analyze right part, so we will do like this. Now, let us say we assume we analyze left part. Okay, because in the method of sections we only have to analyze one part. Okay, only one part, either left or right. If we choose the right part, so we draw these arrows and denote the forces. Okay, now for example, if we choose left part, then we will also assume the tensile forces here like this is force in AB, this will be force in something, right? And this will be also force in something. Okay, now let's see what is the another part. Step 3, choose only one part of the truss and analyze using the equations of equilibrium so that the required member force is found. Okay, now we will choose only one part. Okay, and we will analyze it using what? Equations of equilibrium, right? We know the equations of equilibrium: summation of forces about x-axis is 0, summation of forces about y-axis is 0, and summation of moment at any point is 0. We will take only one part, left part or right part, and apply these equations of equilibrium until we get the required member force. Okay, for example, let's choose here. Now I choose right part. I will analyze this part. Okay, so what I'm going to do, let me show it here. Okay, now I choose this part. So what I'm going to do, I will apply equations of equilibrium. Summation of moment at any point is 0, summation of forces horizontally or along the x-axis is 0. Okay, one by one I will apply these equations of equilibrium. Okay, it will give me the force in AB. Okay, we'll find the force in AB and that's it. Okay, so these were the basic steps. Now let us take an actual problem so that our understanding of the method of section in trusses is very clear. Okay, so let's move on to the example problem. So here we have this example. Now we have this truss and we have to find the member force in EG member. Okay, now where is the EG member? Now this is A, B, C, D, E, F, G. So this is EG member, right? We have to find the member force, the actual force in this EG member. Okay, so what we do, since this is our member, we have to cut here. Okay, now but before that we have to apply what? Step 1 is draw the free body diagram of the whole truss. Okay, now this is a hinge here, so let me convert it into the reactions. Let us say this is AY, reaction at A in the Y direction because Y is upwards. Okay, and X is horizontal direction. Okay, now this X is positive towards right and Y is positive towards up. Okay, and everything is opposite is negative. Now this was a hinge and a hinge have two reactions, right? AY and AX, reaction at A in the X direction. Similarly, we will erase this is a roller. Okay, and in a roller is what? We have only one force. Okay, that is one reaction, that is ky, right? So we draw the free body diagram. Okay, now what we have to do, we have to apply the equations of equilibrium. Okay, so we will apply the equations of equilibrium so that we will find the support reaction. Okay, until now we don't know what is the value of AX, we don't know. We also have to find the value of AY, and what we have to find the value of ky, right? These are the support reactions. Okay, so let's apply the equations of equilibrium. Now let's apply first summation of moment about any point. Let me choose this point K. Okay, summation of moment about K is 0. Okay, so you know length of each member is 1 meter. So this is AC is 1 meter, C is 1 meter. Okay, all of these are 1 meter. Okay, so the total length from this joint A joint to K joint is how much? 1 2 3 4 5, right? 5 meters. Okay, now let us apply this moment equation. Now I'm assuming the clockwise movements, they are positive. Okay, clockwise movements are positive and anti-clockwise movements are negative. So let's apply this. Now AY is going to exert a clockwise movement at K, right? So AY multiplied by, how far is AY normally from K? It is 1 2 3 4 5, right? 1 2 3 4 5. AY is at a normal distance of 5 meters from K point. Okay, because we are finding moment about K, movement of AY about K, so we had to find the distance between them. Okay, so AY multiplied by 5 meters. Okay, we found the moment due to this. Now AX, the line of action of AX is passing through K, so the moment of AX about K is going to be 0. Okay, now then we have this 2 meters, 2 kilonewton. 2 kilonewton is going to exert an anti-clockwise movement, right? So it is negative 2 kilonewton multiplied by, how far is 2 kilonewton normally from K? It is 1 2 3 4, 4 meters, right? 4 meters. So we found the moment due to this. We also find the moment due to this. Now let us find the moment of 3 kilonewton about K. Now 3 kilonewton is again going to exert anti-clockwise moment, minus 3 kilonewton multiplied by, how far is 3 kilonewton from K? It is 1 meter, right? Is there another force? Now this Ky is passing through K, so we will not find moment of Ky about K, because that is going to be obviously 0. Okay, so the sum of all these forces moments is going to be 0. Okay, so what we are left with? We are left with 5 Ay, right, minus 4 2 is 8 kilonewton meter, right, minus 3 1 is 3, minus 3 kilonewton meter. Now remember, this is 5 meter, right? This is 5 meter. All of it is 0. Now minus 8 minus 3 is how much? 8 9 10 11, right? So it is 11 kilonewton meter. So minus 11 kilonewton meter, right? It is equal to 0, right? Now when we take this to the right side of 0, so we will get an equal sign here. Okay, so when we want to find the value of Ay here, Ay is going to be what? 11 kilonewton meter divided by 5 meters, right? So meter and meter is cancel out, we are left with only kilonewton. Okay, so 11 divided by 5 is how much? Let me use the calculator. It is 2.2 and it is kilonewton, right? So we found the value of Ay to be what? 2 kilonewton. Okay, so Ay is 2.2 kilonewton. Okay, so this Ay is 2.2 kilonewton. Okay, now we applied this summation of moment, then we will apply what? Because the equations of equilibrium are summation of moment about any point is 0, summation of forces about y-axis is 0, summation of force about x-axis is 0. Okay, we applied this equation. Now we will apply summation of forces about y-axis. Okay, before that let me erase all of this. Okay, now let's apply summation of forces about y-axis. Okay, summation of force about y-axis is 0. Now remember, y-axis is vertical axis and upward forces are positive and downward are negative. Okay, now 2.2 kilonewton, it is upward, so it is 2.2, it is positive, right? Now this 2 kilonewton is downwards, minus 2 kilonewton, so 3 kilonewton is downward, so it is negative, minus 3 kilonewton, and this ky is upwards, so it is positive, right? So all of it is 0, right? Did I add all the forces in the vertical direction? 2.2 minus 2 minus 3 plus ky. Okay, so Now let us simplify this. Now minus 2 minus 3 is minus 5, right? This is minus 5 kilonewton. Okay, now 2.2 minus 5 is how much? 2.2 minus 5 is negative 2.8, right? Negative 2.8 kilonewton plus ky is 0, right? Now from here ky, what will be the value of ky? It is going to be what? Positive 2.8, right? So we found the value of ky to be 2.8 kilonewton. Okay, I will write it again here. Ky is what? 2.8 kilonewton. Okay, now we will apply now summation of forces about x-axis is 0. Okay, so let me erase this first. Okay, so let us apply this equation. Summation of forces about x-axis is 0. So we have to add up all the forces along the x-axis, horizontal axis, and remember the force towards right is positive and towards left is negative. Now ax is towards right, so it is positive. Ax, do we have another force horizontally? No, right? So this is the summation of force about x-axis and it is equal to 0. Okay, so this ax is 0. Since it is 0, so we'll simply erase it. Okay, it does not exist, right? Because it is 0. So let me erase this first. Now we have found the support reactions. Okay, now what is the another step? The another step is we have to cut the whole truss into two parts, right? Left part and right part, where the force has to be found, right? We have to find the force at EG. This is the EG. Now I can cut this like this, okay, or I can also cut it like this. It is our choice, okay? But remember, it does not have to cut more than 3 members. Now here it is cutting 1, 2 and 3 members only, okay? So this is okay. So let me actually cut it, okay? Sorry, not here. EG is this, okay? So we'll cut it like this, okay? So now this is the left part and this is the right part, okay? So let me separate them a bit. Okay, now okay, so these are the two parts, the left part and the right part. Okay, so let me choose the right part. Okay, I will analyze the right part. Okay, so let us show the tension force in these members. This member is what? FH, right? So this is force in the FH member. Now what was this diagonal member? It was FG, right? So this is force in FG. Okay, now this member was EG, so this is the force in EG member. Okay, because I am going to what? I am going to analyze the right part. Okay, so let me draw it somewhere. Let me draw it here. Now we have to analyze this, right? The last step is we have to analyze this section. I choose the right section. Okay, now we know each member is 1 meter, so we have to apply these equations. Remember the equations of equilibrium, right? We have to apply these equations, right? So before applying these equations, we had to we have to see some forces which are inclined. Okay, now FH, it is horizontal force in EG, it is also a horizontal force, right? Now this force, it is a diagonal force, right? This force FG, it is neither in the horizontal direction nor in the y direction or vertical direction, right? This FG force, it is inclined, it is in between x and y axis, right? Now whenever we have these kind of forces which are neither in x-axis and nor in y-axis, we have to resolve them into two components, x component and the y component. Okay, that's known as the resolution of forces. It is very easy. Now if you don't know about the resolution of forces, I have already made a video lecture on resolution of forces, you can watch it. Okay, now I will also explain it here. Okay, now this force ffg, let me draw lines here. Okay, now we have to resolve this ffg into vertical force. Okay, and we also have to resolve it into horizontal force. Right, now ffg, first we need to find this angle theta. Okay, I will show it here. Where is it? Yeah, here. This angle need to be found. Okay, need to be found. This is theta. Okay, now we know this is 1 meter, this is also 1 meter, and this is also, for example, 1 meter. Since this is equal sided triangle, okay, so each angle is equal, everything is theta inside. Okay, so each angle in a triangle which have similar sides, each angle is equal to 60 degree, right? Because the sum of angles is 180 degree, so 60 plus 60 plus 60 is 180. Okay, so the theta we have is 60 degree. Okay, so where is it? So this theta is 60 degrees. Okay, let us write it here. This theta is 60 degree. Okay, now so this is going to be what? This is going to be ffg. Let me elongate it a bit, let me enlarge it first. Okay, so that you understand well. Okay, perfect. Now this is ffg sine of theta, this component, and this component is ffg cosine of theta, right? This is the sine component and this is the cosine component of ffg. Okay, so we have resolved this force. Now let us apply these equations. Okay, let's first apply summation of moment. Now let me find some space here. Now summation of moment, let us uh, find the moment about this point was k. Remember, this was k point. Summation of moment about k is 0. Okay, now assuming clockwise movements are positive and anti-clockwise movements are negative. Okay, so let us apply these equations. So now FEG is the line of action of FEG. This force is passing through K, so the movement due to this force about K is going to be 0. Okay, so we will not consider this. Also the ffg cosine theta component, it is also passing through K, so it is going to be the moment due to this about K is going to be 0, so we will also not consider this. Okay, now f similarly, now let's come to this part, ffg sine theta. Okay, ffg sine theta. Now ffg sine theta is this part, right? This, it is like this, right? So this is going to exert a clockwise movement at K, so the moment is going to be positive sine theta multiplied by, how far is this arrow? Normally from K point it is 1 meter and this is 1 meter, so 1 and 1 is 2 meters. Okay, 2 meter, so we found the moment due to this, right? Now we have this fh, right? Now it is going to exert an anti-clockwise movement, so it is fh multiplied by, how far is ffh normally from K? So the normal distance is going to be this, right? Okay, now this total angle is 60 degree, right? Because this is theta, this is also theta, everything is 60 degree. As we found before, this is theta, everything, every angle is 60 degrees, right? 60 degree, 60 degree, everywhere is 60 degree. Okay, so because this is 60 degree, so half of it, this angle is what? This is 30 degrees. Okay, So we have to find this normal distance, right? This is the normal distance between FH and K, right? So how do we find this normal distance? Now this length is 1 meter, right? Because each member is 1 meter. So how much is this? Now this is the theta angle. So this will be 1 meter multiplied by cosine of 30 degrees, right? This is the, you know, this is the cosine component. This is 1 meter, so the theta is here, so this is the cosine of 1 meter, right? This length is the cosine of 1 meter, cosine of 30 degree. Okay, let me show it here. I think perhaps you know, for example, let us say this is 5 meter. Okay, this is theta. Okay, now this length is what? This length is 5 multiplied by cosine of theta. Okay, so the normal length is 1 meter multiplied by cosine of theta. Okay, so I'll write 1 meter multiplied by cosine of 30 degrees. Okay, theta is 30 degrees here. Now let us find another forces. Now this force is here, right? This force is how much? Let me find it here. This force was 3 kilonewton. Okay, yeah, this force was 3 kilonewton. This force was 3 kilonewton. Okay, now it is going to exert an anti-clockwise moment. Okay, about point K, so it is going to be negative 3 kilonewton multiplied by, how far is 3 kilonewton normally from K? This is the distance, right? So this is 1 meter. Okay, so we also found the moment due to this. Okay, now moment due to 2.8 is going to be 0 about K, right? Because it is passing through K. The normal distance is 0, so the moment will be 0. Anyways, let me check if we find the moment of all the forces about K. We found the moment due to this Fg sine theta. We also found moment due to this because they are going to be 0. Ffg sine theta. Now Ffh, yes, we found the moment due to all the forces. Okay, and we have to equate it to what? Equate it to 0, because what? Summation of moment is 0. These are the equations of equilibrium. Okay, now let us simplify. Now theta is what? 60 degrees. Okay, now 6 sine 60 multiplied by 2 meters multiplied by 2. Okay, let me calculate it. 2 multiplied by sine of 60. Now this is 1.732. Okay, all of this is 1.732. Okay, so this becomes 1.732 meter, right? Multiplied by force in Fg minus, now 1 multiplied by cos 30. 1 multiplied by cos of 30, it is 0.866. Okay, minus 0.866, it is meter, right? This is meter, multiplied by force in Fh minus, now this is 3 multiplied by 1, right? So 3 multiplied by 1 is 3, and it is kilonewton meter. Okay, kilonewton meter, it is equal to 0, right? Okay, so let me call this as equation 1. Okay, let us call this as equation 1. Okay, everything, this is equation 1. Okay, this is equation 1. Okay, now we have applied this equation and we have applied this equation and we got an equation. Okay, now let's apply this equation. Okay, so let me erase everything first, then we apply. Okay, let me move this equation to downside. Okay, now let's apply this equation. Now summation of force about y-axis, summation of force about y-axis is 0. We are going to apply this, so we have to sum up all the forces in y direction. Y direction is vertical direction. I'm assuming upward forces are positive and the downward forces are negative. Okay, now this is Fg sine theta, this is upwards Fg sine theta. Theta is 60 degree, I will write 60 degree. It is upwards, so it is positive. Now this 3 kilonewton is downwards, minus 3 kilonewton, and this 2.8 is upwards, so it is positive 2.8 kilonewton. do we have another force in the vertical direction? Let me check. We wrote this, we wrote this, we wrote this. I think these are all the forces in the vertical direction. Now this is the sum of these forces and we have to equate it to 0, right? We have to equate the sum to 0, so we did that, right? Now what we will get here, we will get the value of FG, right? Force in the FG. Now minus 3 plus 2.8, how much is it? It is minus 0.2, right? So let me erase all of this. This is minus 0.2, it is equal to 0. So now when we throw this 0.2 to the right side, it is going to be equal sign, okay? Now from here we will get the value of FFG. It is FFG is what? 0.2 divided by sine 60, right? So I will put sine 60 in the denominator, right? So let me use a calculator to find the value. 0.2 divided by sine 60, it is 0.231 kilonewton. Okay, we found the force in FG member, but we don't have to find the force in FG member, right? What we have to do, what is asked, let me show you. We have to find the force in the EG member, right? So this is the force in FG. Okay, now we will substitute the value of FFG here. It is 0.231, right? So this is going to be multiplied by 0.231 kilonewton, right? Now from here we will get the value of FH. Okay, so from here force in the FH is going to be what? Force in FH is going to be what? Let me rearrange this equation. Okay, so this is force in FH. This is negative 0.866 meter multiplied with this, right? Negative this, it is going to be equal to, I will throw these terms to the right side. Okay, so this is negative, right? This is negative 3, it is going to be positive 3 kilonewton meter, and this thing is going to be negative minus 1.732 multiplied by 0.231, and it is kilonewton meter. Okay, so let me use a calculator to find the value. It is 3 minus 1.732 multiplied by 0.231, right? It is 2.6. Okay, 2.6 kilonewton. Okay, now we have minus 0.866 multiplied by FFH is equal to this, right? It is like this, minus 0.866, this is kilonewton meter, right? Because the units are kilonewton meter, right? So minus 0.866 meter multiplied by force in FH, it is equal to 2.6 kilonewton meter, right? Kilonewton meter. So from here I will get the value of FH to be what? 2.6 kilonewton meter divided by negative 0.866 meter. Okay, so meter and meter will cancel out, so the whatever it is going to be in kilonewtons. Okay, so this, let me use a calculator to find the value. It is 2.6 divided by negative 0.866. Okay, it is minus 3 kilonewton. Okay, so we found the value in FH to be minus 3. Okay, let me write here, force in FH is negative 3 kilonewton. Negative means this is not in tension, it is basically in compression. Okay, let me write what we found. Okay, we also found what? Force in FG, right? Force in FG was Fg, it is equal to 0.231 kilonewton. Okay, now we have applied this equation also. Now I will erase first, then we will apply this equation. Okay, so let me erase everything first. Okay, so let us now apply this equation. Okay, summation of force about x-axis is 0. Okay, now I have to sum up all the forces about x-axis. X-axis is what? The horizontal axis. Okay, so we have to sum up all the forces in the horizontal direction, and I am assuming the forces towards right, they are positive, and the forces towards negative, towards left, are negative, right? So now forces in the horizontal direction are these: FFG cosine of theta. FFG cosine of theta is 60 degree, right? So I will write 60. So this was one force. Now then we have another force, is this FEG. It is also in the towards left, right? So now this was towards left, so it is negative. This is also towards left, so it is negative. Force in EG. What force do we have in the vertical direction? Horizontal. Now this force, it is also towards left, right? So it is negative, minus F FH. Now basically let me tell you first one thing. Now force FH is 3 kilonewton. Okay, negative 3, it means it is in what? It is in what? It is in compression. Okay, so the arrow is towards the joint. Okay, now so now I can say force is 3 kilonewton. Okay, not the negative 3. Why? Because I corrected the direction. Okay, since I corrected the direction, now the value of, no, the use of negative is finished. Okay, that was negative means what? The direction was opposite. Okay, first it was like this, now I change the direction to this, right? To this. Okay, so we don't have to write the value negative again. Okay, now FFH is towards right. Okay, so it is going to be positive what? 3, right? Because FFH is 3 kilonewton. 3 kilonewton. Now do we have another force in the horizontal, the x direction? I think we have only 3 forces, 1, 2 and 3. Okay, I did everything right, so the sum is equal to 0. Okay, so I will equate everything to 0. Now force in FG is 0.231, right? So it is going to be 0.231, right? Because let me show you, it was FFG, right? So I put 0.231 here. Okay, 0.231, it was kilonewton. Okay, multiplied by cosine of 60 minus FEG plus 3 kilonewton. Now when we rearrange this, I will throw FEG to the right. Okay, so it is going to be positive, right? Force in EG. Okay, so when I solve this equation, okay, minus 0.231 multiplied by cosine of 30, let me use a calculator, minus 0.231 multiplied by cosine of 60 plus 3, it is all of this. When we solve this, it is 2.88, okay, kilonewton. Okay, so force on EG is 2.88 kilonewton. Now 2.88 kilonewton, is it positive or negative value? It is positive. Positive means our assumption was right, that the force is in tension, right? Because we assume all the forces are in tension, right? So we get a positive value, it means our assumption was right. This force is in, means it is in, it is a tensile force. Okay, so the force in the EG member, okay, the force in this EG member is 2.88 kilonewton meter. Okay, so that this is our answer. Okay, so this is how we solve the problems using what? Method of sections. Okay, so I think that's it. If you have any doubts, please comment, and see you in the next class. Thank you.